Welcome back to Maths with Mrs. J. So far we've been dealing with indefinite integrals and we've had this plus c hanging around, an unknown constant. There are some circumstances, in fact quite a few circumstances, where you will be able to calculate what that constant will be for the particular function you are trying to find. I'm going to do two examples here. The basic thing that you need to remember is that integration and differentiation are opposite things. All right. So when we're starting here, question 1, it says the gradient of the tangent at a point on a curve. That should be saying to you derivative. All right. Gradient of a tangent at a point is what a derivative is. Okay. So this expression here is like our f dash x. So if we let y be f of x, for example, then our f dash x is given by this. We also have the information that we know when x is 0, y is 7.5. We will be able to use that to calculate what our constant term is. Now, to get f of x from f of x, to go that way we're differentiating, to go this way we are integrating. So this one here, we're going to need e to the 2x times 5 over 2 plus our constant term. Have to divide by 2 because e to the 2x, the derivative of that would be 2, so it will be coming through, so chain rule in reverse, all of that, remember? So f of 0 is 7.5. So we know that 7.5 is 2.5 times e to the 2 times 0, which is 0, plus c. E to the 0, any non-zero base to the 0 is 1. So we've got 7.5 is 2.5 plus c, so obviously c is 5. Now don't stop there. The question didn't say find what c is, it said find the equation of the curve. So the curve has equation 5 on 2 e to the 2x plus 5. You can write it as y equals or f of x equals whatever. This next one is a similar sort of thing. We're given the derivative and a point on the curve and we need to find what that original curve was. So if f dash x is x plus root x, just putting that into index notation before we start to do anything with it. So f of x is going to be the integral of this. Remember, increase your power by 1, divide by the new index. Increase by 1, divide by the new index. Now, dividing by 3 on 2 is the same as multiplying by 2 on 3. Okay, now we know that f of 4 is 10. So 10 is 4 squared on 2 plus 2 times 4 to the 3 on 2 on 3 plus c. How do we work that out? We should remember, hopefully, that 4 to the 3 over 2 is the same thing as the square root of 4 cubed, or the cubed root of 4 and then you take the square root of it, but it's easier to do it this way. Square root of 4 is 2. 2 cubed is 8. So what we're going to be left with is that 10 is 16 on 2, which is 8, plus 2 times 8 on 3, plus our c. So what are we left with? 16 on 3, so that's 5 1/3. So 2 minus 5 1/3 is negative 3 1/3 is our c. Therefore, and again, don't stop there, actually give the function. So f of x is our x squared on 2 plus, I'd be inclined to even rewrite that maybe as 2x root x over 3 minus our 3 1/3. It's okay to leave it as x to the 3 over 2.